thanks to 3dprint.com. And today we're going to be talking to you about HiRAM. HiRAM is a layer by layer 3D printing process, metal 3D printing process like so many others. But here, the guys are doing something super duper interesting. What they're doing is a synchronous hot rolling process. So while uh, the layer is being printed, there's a hot rolling process going around there that kind of more puts pressure on and fuses the layers together. Now that deals with, or hopefully deals with, one of the biggest problems we have is interlayer bonding or layer adhesion, or the fact that, of course, if you stack these layers on top of each other, getting this big sandwich of a part, that part is going to be the weakest in between these layers, of course. Now, of course, if you have this rolling process, a heated rolling process, you may be able to fuse them, get them to bond better, end up with a stronger part. This is being run by Shunyu Liu from Clemson University. And the idea is to get structural parts and much stronger and tougher parts. Now, of course, we all know that fatigue strength is a huge problem for metal 3D printing processes. And this very well may deal with it, mainly meaning that we can get more parts that are like, clamps and structures that'll be much easier to deploy throughout airframes and cars and all sorts of stuff like that. I love this. I thought this was great. It's one of these things where you're like, oh wow, that's actually really obvious, but well, nobody did it for like the longest time, right? And we all know there's a problem with bonding these layers. We all know that laser-based processes work well enough. But how to get those layers to fuse better. Now, this I think is a really wonderful, very elegant type solution. I don't know how well it works. It's a research thing at the moment, but I hope really they make headway in this. And this seems like it could be something that really could be used day in, day out to make much more, stronger parts that will really have a high degree of survivability in the real world. The next thing is Adidas, and Adidas's MC87 4D is a golf shoe that uses 4D kind of midsole and combines it with the Tiverton, which is a 1980s golf shoe. Now, I think this is like the aesthetics of combining this 80s golf shoe and this kind of traditional kind of broguish leather upper kind of thing with the 3D printing thing. Well, I don't know. I think it's jarring. I think it's super interesting. I think it's going to really get you noticed on the golf course if this is like something you're about. And I think it's, I'm not like a golfer type of person or something. This is not something that aesthetically, I really didn't like the older Adidas, the 4D shoes. I didn't think they were very attractive. But this to me is like, it's like kind of like, whoa, I don't know, you can't not notice these things. So I don't know, I think this is wonderful. Now, this is news that again the Usler Adidas carbon kind of triumvirate is moving forward into production into more different models. The price is also quite interesting. It's $250, which is actually you can get a lot of other golf shoes for less, I guess, but is a bit lower than a lot of these other things. And a lot of people, including me, like were thinking that they were going to use this for really high-end models, really timely models, and they're really going to use it for, for like the limited kind of stuff. Like, oh, this designer made this collab, and we have to get them now. But this kind of means that at least the golfing division of Adidas is looking at kind of maybe moving this in kind of a more mainstream use at a lower price point than we've been seeing. So that would be a much more kind of like everyday introduction of these kind of things. And we may yet see it in lots of different sports categories, lots of different kind of product categories at Adidas. We could see these things appear. So it's kind of like, I thought that was a bit surprising, actually. I would not have directly expected this to happen. So I think this is really quite an interesting thing. I don't know if they're doing it because it's more functional. I don't know if they're doing it because they hope it's going to, make everybody wake up to Adidas in the golfing world. I know if it's kind of meant to be a halo type shoe, but I think I think this is really nice. They're touting the energy return properties of this, and the absorption, and the energy return on these shoes has improved. And initially, when you first tried them on, I don't know if you tried on the first Adidas one, they were like walking in bricks. And now, of course, they're a little more springier and a lot nicer to wear. So maybe they're getting closer and closer to the prime time in these things and rolling them out across the brand. So I thought that was actually encouraging news. I've been very skeptical as using carbon as a material for this because it's a thermoset and it can't be recycled. I think we should really try to see if we can make either recycled or recyclable, and ideally recycled and recyclable materials on things that are being produced in the tens of millions, like shoes or billions even. I really think that's a place for recycled materials, environmentally friendly materials, bio-derived ones, sustainable ones. So, and on top of that, initially the performance just wasn't there. These things kept breaking, and the tests I did on them as well, they weren't very satisfactory, and the tests other people did as well. So, but lately we've seen a real notable improvement in these things. Where we've seen people that have been using them for a while now, and it seems like they're edging closer to making this a day in day out product for people. So that's going to be good for the industry. The next thing is it's something interesting again from MIT. This is MIT Style to Fab. This thing is something that's again altogether very obvious. They're using language models, machine learning, text prompts, right, to make custom 3D printed goods. Now, first off, super obvious. Now, if we go a little bit deeper, you'll find that maybe it isn't as obvious as you think. And this is actually quite a novel kind of use of deep learning kind of algorithms, stuff like that. What they're doing is they're taking a model, they split it into functional and aesthetic parts. They analyze the model. So the idea is that they're making a system that could analyze 10 models or hundreds of models, or maybe even all of the Thingiverse, all the models on the web. And they're looking at what elements of these models to customize. What's this aesthetic thing that we can customize aesthetically? What is a thing that's a functional thing that either we have to keep the same or that we have to size up or down, that kind of thing. The user is asked to input, which of course like gives the algorithm more feedback, and maybe the user say, hey, no, this is not actually an aesthetic component. This is actually a functional one. And of course, because it's just going by the geometry is kind of difficult for this tool to really identify which of the parts is a functional part. And it's looking at the different angles and trying to find out that draft angles or angles that look like a certain thing or that looks like a certain faster type of thing. That's going to be a functional thing, while other ones are aesthetic. But so I don't know how well this works day in day out, but think about the impact something like that can have. You could just at one point, let this loose on Thingiverse or Cults, whatever the hell you use, and then it could have everything, make everything a certain color or make everything a certain size, and do it in an automated way. Now, of course, we know with this kind of stuff, this machine learning stuff, I've called it to a lot of people. I just said, look, it's a bit like T9. If you're old enough to remember that you have this on the Nokias of old. You had this thing where it went WH. You typed in W and WH and then A, right? With these really weird keyboards, you had to press 3 times to get A and stuff like this. If you're too young, I apologize. You're never going to understand this, but you would have like a keyboard with like 10 keys on it, and then all the letters were divided up on it, and 1 press was the first letter, and 2 presses with the second one, and 3rd press was the 3rd letter. Anyway, so then it had this adaptive text, this predictive text keyboard, and it would go W, H, A, and then it would say T. It would just all of a sudden magically say T, right? And then it's not like, all of a sudden this magical T9 predictive text thing on your Nokia 20 years ago could really predict what you were going to say, right? If you were typing WH and then it would say, is it which or what? It's not like it's like, reading your mind or anything, or it's creating words or it understands language. No, it's just doing predictive text based upon what is the most likely word to follow. And, a lot of these times, of course, these machine learning things have gotten a lot smarter, but let's not forget that it's essentially the same thing, right? So it'll take a while for this to go into a part where it's like, it's much more into an automated system that works much more of the time in a very logical way. But I think this is really encouraging. A lot of people don't know how to do CAD. There's only about 2 million or so people that are like CAD pros or very good at CAD software that can really make anything they want. And the rest of the people on the planet, the other 8 billion, can't. Right? It takes about 2,000 hours to learn CAD. It's nothing as much about that has changed over the last decade or more, right? So there's no real super simple CAD. There've been like, Fusion 360 is very powerful, very accessible, cost-wise, and very accessible kind of use-wise compared to like CAD packages like Maya, whatever, right? So there has been some improvement there, but there hasn't been like, super, super simple CAD hasn't gotten everywhere. So a tool that could really customize and really make things much, much simpler and really get everything in the color you want or the texture you want or the size you want, that could be really very exciting. And there have been a bunch of these types of systems come out. And this is the one where I'm thinking it's another development. And I think, if you fast forward 5 to 10 years, I would expect someone to be able to crawl Thingiverse and then develop a tool that works for customizing all these things. So I think it's great work. This comes from Stefanie Mueller And well, she's actually the professor around it. Stefanie Mueller is, of course, the associate professor at MIT, electrical engineering and computer science at CSAIL lab. And the person who probably did the work on this, and most of the work, is Faruqi. And I think this is wonderful work. And I think, I don't know if this is going to be the holy grail, but hey, imagine just another 5 to 10 years of work on this. And we're going to get somewhere where you can just plaster whatever texture, whatever shape, whatever size you want on these things. So I think this is really fantastic news. Anyway, my name is Joris Peels. This is another edition of 3D Printing News Unpeeled. I hope you have a great day, and I hopefully, this was useful to you.